Okay, good morning. So I'm waiting here for you to join. So we are only 15 online now. Okay. I don't know why there is so much delay here. We are only 19. Should I start now? I think somebody shared the link, so if you're confused where to look for, you can just click on that link. Okay, so today we want to talk about trigonometry, but this is nothing new at all. I want to talk about trigonometry in right-angled triangles. So this is more or less a repetition of what you have studied before. But then, of course, from the next session, we go to something new and very important. So it's very important to learn this chapter very good, because next year we will start with a continuation and completion of this chapter. Okay, so consider you have a right-angled triangle. This right-angled triangle has a right angle in it, and then there are two acute angles, yes? Acute angle is an angle which lies between 0 and 90 degrees, strictly between 0 and 90 degrees. So that's called an acute angle. Okay, now we want to actually associate with each one of these two acute angles 3 numbers. We can also associate more numbers, but in the book we have only 3 numbers. One of them is called the sine of the angle, the other one is called the cosine of the angle, and the tangent of the angle. Okay, so if you remember, for example, if I consider this acute angle B, I can talk about sine of B, I can talk about cosine of B, and I can talk about tangent of B, yes? So this is the definition that I am presenting here for you. So if you are interested in sine of B, you need to look at the side opposite to the angle. So if this is your angle, side opposite to the angle is this side. You measure its length, for example. Let me, by the way, use this convention that if you have a triangle with capital A as a one vertex, the length of the opposite side is denoted by little a, lowercase letter, corresponding to that capital letter. And then if this is B, the length of the opposite side is denoted by a small b, and the same thing here for C. So if I ask you what is A, B, and C, you would say that these are corresponding lengths of these sides. So if I am interested in sine of b, I go and measure the length of, and I divide it by the length of the hypotenuse. Yes, so it becomes a. If I am interested in calculating cosine of the angle, I need to go to this angle. I need to pick up the length of the adjacent side. So this you need to be careful. If I have these two sides, both of them are adjacent to this, but I will not call this adjacent in this context because there is a better name for this one, and that's called hypotenuse, yes? So when I say adjacent, I mean this one, not that one, even though technically both of them are adjacent to the same angle B, yes? So when we say cosine of B, I take the length of the adjacent side by this explanation. Adjacent side is C, and I divide it by the length of the hypotenuse again. And if I want to calculate tangent of B, I go and take the opposite side, okay, which is B, but divide it by the adjacent side for the same reason. Adjacent side here is A. So this is the definition. So in principle, if I want to write something like this, I would write sine is defined to be opposite. Let us write this for opposite divided by hypotenuse. And cosine is defined to be adjacent divided by hypotenuse. And tangent is defined, this semicolon equals to means defined to be opposite divided by the adjacent. So this is the thing that you need to remember. Of course, this is given in the formula sheet, but I think it's so fundamental, it's better to have it in your memory. Okay, and please, if you have any questions, you can ask me through Zoom as always. Okay, now let us write something next to it. Let us change our target from the angle B to another angle C. So you see this definition, I have explained orally, I haven't written it here. This is sine of an acute angle. We are only working in a right angle triangle. I emphasize here, right angle triangle. And sine and cosine and tangent are only defined with two acute angles. These doesn't work for this angle A. Yes? So only acute angles, not this right angle here. So if I ask you, let us write the same thing for the other acute angle. So the other acute angle is C. So I can talk about sine of C. I can talk about cosine of C. I can talk about tangent of C. Okay, so the sine of C is the opposite side. This time is little c divided by the hypotenuse, which is still A. And then cosine of C, which I have it here, is the adjacent side. So again, there are two adjacent sides to C. One of them is A, one of them is B. This one is the hypotenuse. So by adjacent here, I mean B divided by A. And then what I get here is opposite one, which is C divided by adjacent. Okay, so before going any further, there are some informations because you have already studied these things. So let us try to understand a little bit deeper things here. So for example, you realize this B over A appears on the first line in the on the left column, but it appears as a second row in the second column. So B over A is the same B over A. So it means that sine of B is equal to cosine of C. And that's a very important relation in trigonometry. And vice versa, sine of C is equal to cosine of C. So it's a very important relation in trigonometry. If I have two angles that add up to 90 degrees, yes, because you know that in a right angle triangle, B plus C, angle B plus angle C is 90 degrees. The angles whose sum is equal to 90 degrees are called complementary angles. So if two angles add up to 90 degrees, then they are called complementary angles. For example, like 30 degrees and 60 degrees. I don't know, like 20 degrees and 70 degrees. But we have a very nice relation. if I have two complementary angles, sine of one of the angles is always equal to the cosine of the other angle. So this is so important, so I would prefer to write it as a remark, okay? So the sine of an acute angle is equal to cosine of its complement, and vice versa. Okay, so if you tell me, do you know sine of 20 degrees? I would say no, I don't have it in my memory. This is not some number, by the way, that I have it in my memory. But if you ask me the same question for cosine of 70, I don't know. But I know something. I know that this number, whatever it is exactly equal to this. You can confirm it using your calculator. By the way, it's very important for this exam coming. There are two modes for trigonometry in your calculator. One of them is the degree mode, and the other one is the radian mode. The radian mode we will study in Math 4. So make sure that always your calculator for this course is in degree mode, but otherwise you will get wrong answers. And if you want to check it, immediately punch this, for example, in your calculator. If the answer happens to be equal to 1, then it means that you are in the correct mode. If sine of 90 turns out to be a different number, it means that your calculator is in the radian mode and you have to learn how to switch it back to the degree mode. Okay, for example, if you go in your calculator and punch this, you will get 0. So this means that these two numbers are the same. Even if you ask me what is sine of 20, I don't know. What is cosine of 70, I don't know. But I know that they have to be equal. So that's a very, very important thing. We will work with it even in Math 4. So if two angles add up to 90 degrees, this you need to know. Another thing that is important here is that let us calculate this number to power 2 plus this number to power 2. One thing that I want to mention, you are not allowed to write SIN. SIN doesn't have any identities, yes? So you need to put an angle in front of it, and then sine of that angle becomes a number at the end. So be careful. You are not allowed to write SIN or COS or TAN. You have to put an angle in front of it. Yes? And if you put an angle in front of it, then it becomes a number. Okay? Let us calculate, for example, this number to power 2 and plus this number to power 2. Yes? So let us see. The reason that I am putting it in power 2, because this is a famous, very famous combination in trigonometry. So let me calculate sine of b to power 2 plus cosine of b to power 2. You might say that, okay, how should I be able to calculate it? Because you haven't given me the number, the angle b. But this happens to be independent of my choice for b. For every angle, this becomes equal to 1. It doesn't matter what that angle is. As far as this angle is an acute angle, sine of that angle to power 2 plus cosine of the same angle to power 2 becomes equal to 1. Let us confirm that. So how I can confirm? Sine of b is defined to be b over a. So I would write it as b over a to power 2 plus cosine of b is c over a to power 2. Then what you do, it becomes b squared over a squared plus c squared over a squared, yes? And the denominators are the same, so I would write a squared, and then I have b squared plus c squared. But you know that this setup is in a right-angled triangle, and I can invoke actually the Pythagoras Theorem. So the Pythagoras theorem tells me that b squared plus c squared is exactly equal to a squared. So in the numerator, I can just replace that expression with a squared, and the denominator is a squared. So you see that it doesn't matter, because a squared, whatever it is, the same denominator, it always becomes 1. So it is very, very important fact in trigonometry. Sine of any acute angle, for the time being, I am only talking about acute angles, but the next lesson we will go to any type of angles. Even negative angles. We will talk about them later, okay? But for the time being, it doesn't matter what acute angle I have. If I calculate that combination, it becomes equal to 1. So let me write this as also a very important remark here. So remark. Okay, before writing this remark, I want to write you here a convention. So people usually doesn't write it in that way. We don't use pair of brackets, even though if you write this, it is totally acceptable and correct. But when you read the books, usually they avoid to put that pair of brackets. Okay, but if they avoid to put the pair of brackets, and if they put here too, then you might be confused that this is b being squared, even though in computer, when you want to type it, usually computer programs type it in that way. So this is a little bit ambiguous. So the convention is not to put 2 here, we put 2 here. And we read it as sine squared b, okay? Even though technically it means sine b squared. I think, yeah, that is the correct way of reading it, because we first calculate sine of b and then square it. But yeah, sloppy language tells me that this is sine squared b. But you understand that this means the same thing. Okay? And it doesn't matter if this is 2, 3, 4, or any exponent. It doesn't matter. You just write that exponent here. So what if I write sine to the 5x? It means that sine of x and then to power 5. So this is something that you need to know. Okay, now by this convention, I would say that if for any acute angle theta, this is a Greek letter, so usually we use for angles. For any acute angle theta, sine squared theta plus cosine squared theta is equal to 1. It's a very, very important fundamental rule, theorem actually, in trigonometry. Sine squared of any angle plus cosine squared of the same angle, it becomes 1. So for example, if I ask you what is sine squared of 65.7 degrees plus cosine squared of the same angle, even if I don't know anything about these numbers, but I know the exact value for this, and the exact value is equal to 1. Okay, let me ask you one question. Can you answer this one for me? So sine squared of 20, so let me write sine squared of 21 plus sine squared of 69 degrees. Do you think we can calculate the exact value of this combination? If yes, you can just communicate with me through Zoom. Yes, might be my, yeah, I cannot hear anything from you. Did you answer or not? No, my volume is okay. So is it clear for anyone to see what we can do? We want to use 2 remarks, this remark and that remark simultaneously. What type of angles are 21 and 69? If you add 21 to 69, the number becomes 90 degrees. So it means 21 and 69 are complementary angles. Yes? And then we learned that if I have complementary angles, the sine of one of them is equal to the cosine of the other one and vice versa. So for example, if I want to answer this question mark, I just copy and paste the first part, which becomes sine squared 21 degrees plus. Instead of sine of 69, I can write cosine of 21 because 21 and 69 are complementary angles. So sine of 69, according to this remark and what we learned here, is equal to cosine of 21. So instead of sine of 69, I put cosine of 21, but I have to square it, so I have to square it here as well. And then everyone now knows the answer, because this is a so famous combination, you should have it in mind. Yes, sine squared of 21 plus cosine squared of the same angle is always equal to 1. Any questions? Okay. Yeah, I want to here I want to review a little bit about what we learned in the previous year. There are famous angles. Okay, before going on, let us understand something. There are some limitations for the number that the sine can attain. Yes, because you see, sine is the length of the opposite side to its hypotenuse. Yes. And you know that in a right angle triangle, the length of the hypotenuse is actually greater than this length of the other sides. So if I ask you what type of fraction is this, you would say this fraction is definitely smaller than 1. Yes? So it is important, it's here and here. C is smaller than A, so this fraction is smaller than 1. B is smaller than A, so this fraction is also smaller than 1. So sine of an acute angle cannot be greater than 1. And of course, it is a positive number because these are lengths of these sides and they cannot be negative. So I'm dividing two positive numbers together. So we can say that the sine of any acute angle is a number between 0 and 1. It cannot be equal to 0. It cannot be equal to 1. It is restricted between 0 and 1. The same is true for cosine. That's the same story. So cosine of an acute angle is also between 0 and 1. So that's also good to write it down somewhere here. So if theta is an acute angle, what we have, we know that the sine of theta is between 0 and 1. And then cosine of the theta is also between 0 and 1. These are really important facts that I'm emphasizing here. So you need to have them in mind. Otherwise, you will face a lot of troubles in trigonometry. But there are no limitations for tangent. Tangent can be, of course, tangent also should be positive because I am dividing two positive numbers, but it can be very large. It can go, in principle, it can go up to infinity. To understand that, why there are no limitations, so let me also put an empty space here for tangent. Let us understand that tangent can be any positive number that you like in principle. It depends to these values. Okay, if I want to understand that, we can do something like this. So, for example, let me just draw I want to make the adjacent side. Okay, nobody told me that I made a mistake here. Sorry. I wrote tangent of B should be the opposite side divided by the adjacent. I wrote this one correctly, but I made a mistake here, and you didn't mention it to me. Okay, so this was my mistake. Tangent of B is B over C, not B over A. I wrote there correctly, but I wrote here a little bit wrong. And by the way, you also find a very nice relation between these two. We can just talk about this. What do you see here? If two angles B and C are complementary, there is a very nice relation here as well. We learned that if two angles are complementary, sine of one of them is equal to the cosine of the other one and vice versa. But we see that tangent of B is B over C, tangent of C is C over B. So what we can conclude, that tangent B and tangent C are reciprocal with respect to each other. So it means that if I multiply tangent B by tangent C, B over C will be multiplied by C over B, and it becomes equal to 1. So we can also write this as a remark. That's also good, but not as important as the previous one. But anyway, let me write it down before cleaning it. So remark, and let me write it in this way, alpha and beta are complementary angles then tangent of alpha multiplied by tangent of beta, it's equal to 1. So that's also important, but not as important as the previous one. Yes, that's good to know. Okay, now let us go back. I want to convince you that in principle, tangent of any acute angle can be infinitely large. Okay, so how can I convince you for that? I would say that, let me, this tangent is the opposite side divided by B. So here, for example, if I consider this triangle, yes, take this one. If I ask you what is tangent of B is equal to the opposite side, so let me call it X in this picture, divided by the adjacent side. Yes? Okay, and now you know that the extreme case is if I draw a right angle here. If I draw a right angle here, these two lines would be parallel, and I will not have any right angle triangle. So I need to be a little bit smaller, okay, in principle. If I increase the value of B a little bit more, so what is happening? Look, what is happening? This Y is remained fixed, so the denominator is not changed. But the value of the X has increased to this new value. So it means that this new angle is bigger, but it's still smaller than 90 degrees. So it is still acute angle, but its tangent is bigger than the tangent of the previous angle. But hopefully you are convinced I can increase the angle a little bit more, and then the intersection will go higher. Now the denominator is left the same. So this is now this new angle, but the opposite side has increased in size. So the value of X over Y is going up again. And I hope that you see there is no limitation how much I make it big. There's no problem. I can make it arbitrarily big. Yes? So I can make it bigger, then this intersection point will go higher. You see? If I just stand on this extreme, the intersection will jump to infinity. But even if I am a little bit less than 90 degrees, I will have an intersection, but that intersection point would be very, very high. So this means that this fraction can be made very big in principle if you want to. So it means that if I want to add something in my list, I would say that tangent theta is greater than 0, but there are no upper bound from it. So usually people write infinity. So you see there is a big difference between sine and cosine and tangent. Sine and cosine are limited between 0 and 1, but tangent is between 0 and infinity. Okay? So these are the things that you need to know very well. Okay. Mainly, this this was a little bit of theory, but usually what you need to learn is to calculate things using your calculator. Okay. Okay, now there are some famous angles in trigonometry. The reason they are famous is because we can calculate the value of sine, cosine, and tangent of those angles exactly. Okay, and usually without calculator. So I want to talk about those angles here. So the angles that we are interested to talk about today is 30 degrees, 45 degrees, and 60 degrees. Okay. Before talking about this, one thing is might be a little bit not clear. I don't know if that's a question for you or not. I told you that if I want to calculate, for example, sine of 30 degrees, for example, what should I do? I need to start with a right angle triangle so that one of its acute angle is 30 degrees, yes? So it means that I draw a right angle triangle whose one of the acute angles is 30. Assume that this is your right angle triangle. What might, and then I ask you, okay, sine of 30, if this is A, this is B, this is C, this is A, this is C, this is B. If I ask you what is sine of 30, you would say sine of 30 is equal to B divided by A. Okay, but one thing is that, do you think this is a little bit ambiguous or not? Which triangle I can draw? Because how many right angle triangles are there so that one angle is 30 degrees? There are infinitely many, yes? For example, if I can draw it, I can just draw it something like this. Yeah, of course, it is hard to draw with hand like this. But if I draw these two lines parallel, this is still 30 degrees. Okay, and then this, let me call it A prime, B prime, and C prime. And then, of course, this becomes B prime, A prime, C prime. And then so if I ask you to calculate sine of 30, might be one of you draw this triangle, someone else draws this triangle, yes? So then that person will calculate sine of 30 degrees by writing the opposite side divided by the hypotenuse. But at least intuitively it is clear B is much smaller than B prime, A is much smaller than A prime. Okay? So how do you solve this problem? Which triangle I should use to calculate sine of 30 degrees? This one or that one? And of course you immediately realize there are infinitely many of them. So which one I should use to calculate sine of 30 degrees? No one answers today, but hopefully you can hear me. Is everything okay? Might be I'm talking to myself. Can you hear me? Some of you can talk to me through Zoom. Can you hear me through YouTube?
We can hear you.
Okay, thank you. At least I know that you can hear me. Okay, so which one I should use? Do you have any? Because that's the puzzle, yes? If you put sine of 30 in your calculator, do it 100 times, you always get the same answer, 0.5. Okay? So which one should be the base of your calculation? This triangle, or any other triangle, right angle triangle with an acute 30? The answer is that it doesn't matter.
It doesn't matter.
Yes, so how can you elaborate more? Why it doesn't matter?
I think it has to do with the ratio.
Okay, so what you say is that even though B is smaller than B prime, A is smaller than A prime, but the ratio of B over A becomes exactly equal to the ratio of B prime over A prime. So that's very good. Otherwise, we would be in trouble. Yes. Why B over A is equal to B prime over A prime? That is some theorem in Matematik3c. You learned about similar triangles. Yes. So this triangle has two angles. One of them is 90 here. One of them is 30. This bigger one has 90 and 30. And then there was a theorem, if you remember in Mat1c, that if two triangles have two equal angles, they are similar. And if they are similar, it means that the ratio of B to B prime is equal to the ratio of A to A prime. And if this is the case, I multiplied both sides by A prime B prime. So this becomes A prime B equals to B prime A. And then what I do, I divide by, so here I multiplied by A prime B prime. And here I will divide by A prime. I divide by A prime. If I divide this by A prime, I have to divide the right-hand side by A prime as well. Then the left-hand side, A prime is cancelled. I get B over A. On the right-hand side, A is cancelled. I am left with B prime over A prime. So you see that B over A is equal to B prime over A prime. So actually, it doesn't matter. Do you use this triangle or that triangle? Even though individually, these sides are different in size, but the ratios are the same, and that is very good. This is why it doesn't matter which triangle you actually use. Okay. Is that understandable? So whenever you want to calculate the sine, cosine, tangent of any one of those angles, it doesn't matter which triangle you choose, but you need to choose a triangle so that one of the acute angles is equal to the angle that you are interested in calculation. Okay, I would prefer here to start with 45. This is the simplest one, and we can solve 30 and 60 more or less together. Okay, so let me just clean this so you understand that it doesn't matter. Whenever you want to calculate, it doesn't matter how you draw, how big or how small you draw your triangle. So the reason that I want to start with 45, because this is the simplest possible case, yes? So I draw a right angle triangle, and for simplicity, you understand it doesn't matter. So let me just do it like this. I take this one to be 1 unit. Yes, I take this one to be 1 unit. You might say, why are you allowed to choose the 1 unit? Because I just confirmed that. First of all, if I complete this right angle triangle, and if I ask you what that angle is, hopefully you agree with me, this is exactly 45 degrees. Yes, because this is a right angle triangle. This side is 1, this side is 1. So this is isosceles as well. So this means that these two angles should be the same. The sum is 90, so each one of them should be 45 degrees. You might ask, why do you choose it equal to 1? Choose it equal to 2. Yes, I can choose it equal to 2, but here I just convince you that this is not a big deal. It doesn't matter what are the sizes. Okay, so I can just work with 1. And if I ask you if this is 1, if this is 1, what is this one? You immediately use the Pythagoras Theorem. So this is the square root of 1 to the 2 plus 1 to the 2, which is the square root of 2. And now if I ask you what is sine of 45 degrees, you would say this is the opposite side, which is 1, divided by the adjacent side, which is the square root of 2. Okay? And then the same story for cosine of 45. By the way, 45 and 45 are complementary angles. So the sine of one of them is equal to the cosine of the other one. So I don't need to calculate anything at all. It is also square root of 2. 1 over square root of 2. And then what is tangent of 45? Tangent of 45 is the opposite side divided by adjacent side, which is 1. So these are the exact numbers that we get. Yes? So let me just draw a table. I want to complete it for you today. So this table is given in the formula sheet. Yes, but if you start solving problems a lot, more or less you will be able to have them in your memory, okay? So today we want to complete this table. So here I have, let me write it in this form. Here I have my angle theta, and I want to concentrate on three famous angles in trigonometry. One of them is 30, the other one is 45, and the other one is 60. We will have more famous angles later when we talk a little bit more advanced trigonometry this year. So theta, I will write sine of theta. Here I would write cosine of theta, and then I would write tangent of theta. Okay, so for 45, I got this number 1 over square root of 2. This one is 1 over square root of 2, and then this one is 1. The reason that I wrote it on the left-hand side is because some books write it a little bit different. I want you to know that one as well. So 1 over square root of 2, I can write it 1 over square root of 2 multiplied by square root of 2 divided by square root of 2. This is 1. I am multiplying this expression by 1, so I will definitely get this one. What is the benefit of doing that? Yes, usually people prefer not to write thirds in the denominator, okay? And then I multiply that by that, it becomes square root of 2, and the square root of 2 times square root of 2 is 2. So some books prefer to write it in that way, some books prefer to write it in this way, but it is crucial to immediately realize that these two are the same. So in principle, if a is positive, 1 over square root of a is exactly equal to this combination. Okay, so I put it here. It is the square root of 2 over 2. I don't know which one your book has chosen, but it's very good to know both. So this is about tangent of 45. But what can I do for 60 degrees? Okay. So now I want to go to 30 or 60. So let us concentrate here on 30. Okay, so for 60 and 30, this is a little bit strange. I have to start with a right angle triangle, but let me start with an equilateral triangle, okay? So equilateral triangle, it means that all the sides are the same. So let me take it 1, 1, and 1. Okay, if this is the case, then you know that this angle is 60, this angle is 60, this angle is 60, but I cannot write sine of 60 degrees is equal to this one divided by this one, because this only works in a right angle triangle, but this is not a right angle triangle. But the trick is to draw this height. Yes, my picture is very awful, but if you draw it correctly, then this will bisect this angle to 30 degrees and 30 degrees. And these two sides would be the same. So it means that this length becomes 1 over 2, and this length becomes 1 over 2 as well. If you draw it very precisely, then you will get this information. Okay, I cannot draw it exactly by hand like that. Now you see that I have my right angle triangle that I need, and the good point is that the angles involved are 60 and 30. Okay, so that was a very nice way, because it doesn't matter which right angle triangle I am choosing. If I have a right angle triangle, any of them, that one of the angles is 30, I can talk about sine, cosine, tangent of 30. Okay, and this is the way that we describe it. And then you immediately realize what to do, because sine of 30 is the opposite side, which is 1/2 divided by the hypotenuse, which is 1. Yes, so I would say that sine of 30, I will choose this one. I could choose this one, it doesn't matter. And then sine of 30 degrees is equal to 1 over 2 divided by 1. But it becomes 1 over 2. Cosine of 30 degrees is equal to this is a little bit problematic. Cosine of 30 degrees is this length, because this is the adjacent one, divided by the hypotenuse. But let me call it h. I don't have it yet. But I can use Pythagoras Theorem to calculate it, yes? So I would say that h squared is equal to the hypotenuse squared minus the other side squared. Okay, so let us calculate it. It becomes 1 minus a quarter, so it becomes 3/4. But I am looking for h. And I know that h is the height and it is positive, so I don't need to put plus and minus. I take square root of 3, I take square root of 4, which becomes 2. So h is this number, is the square root of 3 over 2. So cosine of 30 is the adjacent side, which is h, divided by the hypotenuse. So it becomes square root of 3 over 2 divided by 1, which is square root of 3 over 2. Okay? And then tangent of 30 is equal to the opposite side, which is 1/2 divided by, yes, it is 1 over 2 divided by the adjacent side. Adjacent side is a square root of 3 over 2. And then you see this 2 and that 2 are cancelled, so I get 1 over square root of 3. You remember, for the same reason, I wrote it here. Let me write it with different color. So 1 over square root of a, if a is positive, is equal to square root of a over a, for the same reason that I told you for square root of 2. So this becomes equal. Some books write it in that way. I don't remember which one is written in your book, but some books prefer to write it in this way. So both of them are correct. So now let us fill up the gaps. So sine of 30 degrees is 1/2. Cosine of 30 degrees, we calculated square root of 3. And this one is 1 over square root of 3 is equal to square root of 3 over 3. For 60 degrees, I can start calculating it once more. I can calculate, I would say sine of 30 is the opposite side divided by the hypotenuse. But let us use that complementary angle formula. 30 degrees and 60 degrees are complementary. So sine of one of them is equal to the cosine of the other one and vice versa. Okay, so this means that if sine of 30 is 1/2, cosine of 60 is also 1/2. And if cosine of 30 is a square root of 2, sine of 60 is a square. Sorry, I made a mistake. If cosine of 30 is the square root of 3 over 2, sine of 60 is also the same number. But what can I write about tangent of that angle? Do you remember I told you that if two angles are complementary, tangent of one of them is the reciprocal of the tangent of the other one. So if the tangent of this angle is 1 over square root of 3, tangent of its complement is a square root of 3 over 1. Square root of 3 over 1 is just this one. So that is actually a very, very important table. By the way, you see nothing is new. This is just repetition. This is the first pages in the book. So I want you to remember these things. Next time we will go on. This is included in the book as well. So that is a very important table that I want you to know about. Okay, so that's one topic that I wanted to talk. One thing that we can also confirm here, if I draw a right angle triangle, of course we will talk about this in more detail later. So if I ask you, this is tangent of, if this angle is B, this side is B, this side is C, this side is A. Do you remember, if I ask you what is sine of B, you would say it is B over A. If I ask you what is cosine of B, you would say it is C over A. Yes? Now let me ask you to divide them. So this becomes sine B divided by cosine B. And then I have to divide B over A by C over A as well. But you see that these A's are cancelled, then I get B over C. On the other hand, if I ask you what is tangent of B, you would say tangent of B is the opposite side divided by the adjacent side. So now compare this one with that number. Both of them are now B over C. So it means that we find a nice relation. Tangent of B is equal to sine of B over cosine of B. So you see, tangent of B is equal to sine of B over cosine of B. So it is not only for B, for the time being, this is correct. This is true for all acute angles, but we later learn this is always true, okay? Not just for acute angles, except those values where the denominator becomes 0, okay? You will not face it in a right angle triangle, but later we will see that, for example, cosine of 90 degrees is 0. So it means tangent of 90 degrees is not defined. So we will talk about these things later. But as far as cosine is not 0, that's a safe thing. So I would say that tangent of any angle theta is equal to sine of that angle divided by cosine of that angle, provided that cosine is not 0. Okay? That's also a very, very important relation. So if I want to write the fundamental formulas of trigonometry, I would write them like this. I would write sine squared of theta. I really want you to memorize it. Equals to 1. And I want you to know that tangent of theta is equal to sine of theta divided by cosine of theta. It's extremely important. You see, there are only 2 formulas. You appreciate it. Memorize them. Okay, so here, if I calculated sine and cosine, I didn't need to do it using triangle. I just simply divide them. 1 over 2 divided by that 2 and 2 are cancelled, I get this number. You see here, 45, I divide this number by that number, I get 1. I divide this number by that number, I get square root of 3. So that's very simple. Okay, now let us solve some practical problems using these ideas. There are nice problems, by the way. This chapter contains a lot of nice problems in the book. So I really recommend you to try to solve as many problems as you can. Because the concepts are simple here, but you really, really need to practice a lot. Otherwise, trigonometry would be the trouble of your studies in mathematics all the time. I agree that there are many things that you need to memorize or you need to have the table in front of you to be able to answer. But this is not just enough to have the information in front of you. You have to practice a lot so that you can do it quickly. Okay? So let me solve some examples for you. Yeah, I don't know if I should start with these very simple examples. So for example, I give you this triangle. And these are very simple. I would consider them math, even though it's repeated here, but I would consider it a 1C problem, okay? But let us just make sure that you know that. I give you this figure, and I ask you to calculate x, and you're allowed to use your calculator as well. Okay, so how should I do that? First of all, I see that this is a right angle triangle, and then I have 60 degrees. There are 3 things that I can write for 60, sine, cosine, and tangent. Which one I need to choose? Remember this. Don't try to learn it in this way. I will try everything. No, this will take time. So you see that hypotenuse is given to you. So it means that essentially tangent is useless. Yes? Because tangent deals with the opposite and the adjacent sides, not the hypotenuse. Okay? And then you see that what is wanted is opposite to this. So on the one hand, I have the hypotenuse x divided by the hypotenuse. You use the table. If I ask you find the exact value, so you have the exact value in the table or in your calculator. So you say that I want to find x, I multiply everything by 13. And then instead of sine of 60 degrees in the table, you have square root of 3 over 2. So that is the exact value. If this is expressed, for example, in centimeters, here you should also give me the units. So x is equal to 13 times square root of 3 over 2 centimeters. I will not solve these kinds of problems. But I want you to learn not to write all the details. You need to see which sides are involved and which angles, with respect to the angle given. Either sine is relevant or cosine or tangent. Recognize it and then use it instead of just checking it all the way. Okay. Let me solve, for example, nicer problems here. So one example, for example, would be this. I have given this triangle with these pieces of information on it. So here it is given to be 30 degrees, and then this height has been drawn here. Okay, and then this is given to be 60 degrees, and this is the height is given to be 100. What is wanted from you is this x. So you have these numbers and you want to calculate this height, this x. How should I calculate this? Do you have any ideas? So in trigonometry or geometry, you need to have a little bit logic. But of course, trigonometry and geometry problems could be extremely hard. Okay? But by practice, you can get better and better. Okay, so for example, the thing that comes to my mind immediately, more or less, by practice probably, is that I want to calculate x. Immediately, I see that x is composed of two simpler parts, smaller parts. One part is this one, and one part is this one. Then I try to concentrate. Is there any way for me to find this little piece here and this one there? If the answer to this is positive, then my problem is solved because I add these two numbers together and I get x. So I'm not saying that 100% this strategy works, but at least I need to choose a strategy to start with, yes? So I would say that let me call this one, for example, y. Let me call this one z. And then I realize I'm just doing it in a scratch paper, for example, so that if it works or not. This I understand immediately. X is definitely equal to y plus c. But now I use my energy, concentrate only on one piece at the moment, and that is y, for example. Is there any way that I can find y from here? You see the problem becomes simple. I momentarily ignore what is here. I only concentrate on this piece. Can I write something here? Yes, because this is a right angle triangle, because if this is 90, then the adjacent one is also 90. And then what are the things are involved? I have this angle. I have the sides of the opposite side. So it means that it should be either tangent or sine, because these are only ones that are involved with the opposite side. And then I immediately realize the other one that I am interested in is y, but y is adjacent to 60. So I realize two sides are involved, opposite and adjacent. So I realize that tangent is useful, yes? So I would write tangent of 60 is equal to the opposite side, which is 100, divided by adjacent side, which is y. Okay? And I really want you to learn this. If I have two ratios equal, there are some things that you can immediately write. You can write the product of extremes. These are called extremes in American English, okay, is equal to the product of means. The other thing that if you like to do, you can write the reciprocal of this. Definitely it is equal to the reciprocal of this. I will use them freely, and you're also free to use them in the exam without any explanations, okay? So 3, this is a little bit nice to understand. If I want, I can interchange the extremes. What does it mean? It means that I can put D on top, I can put A in the bottom here, I keep these intact. Yes? And by the way, the reason that this is correct, because if you use this product, it becomes A times D is equal to B times C. That's exactly the same expression. So that is something it's very important to know. You can also do the other way around. You can interchange the means without affecting the extremes. So I keep A and D the same, but I decide to interchange these two. So these are very important rules. Sorry, this is B. These are important rules that if you want, you can use them freely. So for example, here, if I want to solve this problem, I put a 1 in my head here, and I interchange these two. Yes, so what happens? Y goes here, I keep 1 the same, and then I keep 100 the same. I am interchanging y and tangent of 60. So tangent of 60 goes down. Of course, if I want to do it in my head, I don't need to put 1 here and 1 there. So let me clean them. You can do it in your head. And that was my goal. My goal was to find y. I found y. Yes? But of course, I know tangent of 60 is a number there. It's the square root of 3. Do you see it there? So this becomes 1. Let me write everything in centimeters here. So this becomes 100 divided by square root of 3 centimeters. So this is your y. You see, I was able to find y. And now hopefully you understand that I can use the same trick to find z, yes, but in the adjacent right angle triangle. So what can I do? And the same story. 30, it is opposite, it is adjacent, so it means that again tangent is useful in this problem. So I would write tangent of 30 is equal to the opposite side, which is 100, divided by adjacent side, which is z. I use the same trick. I interchange these two because my goal is to find z. So this becomes 100 divided by tangent of 30 degrees. And tangent of 30 degrees is this number. So this becomes 100 divided by 1 over square root of 3. So this becomes 100 the square root of 3 centimeters. And then if I want to calculate x, x becomes equal to y plus z, but y is equal to 100 over square root of 3 plus 100 times the square root of 3. In principle, you can stop here, but let us have some fun with calculating and simplifying this exactly, not using calculator. So what can I do? For example, I can take the common denominator to be square root of 3. So this would be 100 plus, this will be multiplied here. Square root of 3 times square root of 3 is 3. 3 times 100 is 300. And then it becomes 400 divided by a square root of 3 centimeters. But even if you want to write it more nicely, I told you that we usually try to get rid of surds in the denominator. So I can write it as 400 square root of 3 divided by 3. I myself prefer to write it in this way. But technically, this is also okay. But this is something I really want you to learn, to be able to institute. So every one of you agree that this is a better way, this is a better name for this expression, yes. It's a simpler and more compact. So this is the exact value of the x that I was looking for. So these kinds of problems you need to practice to understand the relations more or less immediately. Any questions? There is also one problem here. Let me just try to solve it because I want to learn to teach you two terminologies. These are called angles of elevation, especially in survey and making maps. These words are very ubiquitous. So angle of elevation and angle of depression. Okay. So what are those angles? So assume that this is not very high hill, and then someone is standing here, and here, for example, you have a flagpole, for example, and then you have your whole flag here, and then this person is looking at this, and this is mentioned in the problem itself. So let us assume that this is 20 meters, and then this person is looking at this flagpole, and then it is written in the problem in this way. They say that the angle of elevation of the top of this pole is, for example, 18 degrees. What does it mean? It means that if you draw a horizontal line parallel to the horizon, yes, and then if you connect this to the top point, this angle which is above horizon is called angle of elevation. So angle of elevation. And then it is given in the problem that angle of elevation is 18 degrees. And it has mentioned that the angle of depression of the lowest point in the flagpole is, for example, 22 degrees. I don't know. Yeah, in my picture, it's bigger a little bit. Okay, so this is what I want you to know. If you say angle of elevation, it means that you are looking above horizon. Angle of depression, it means that you are looking below the horizon. Okay, so for example, let us consider this to be 22 degrees. So this angle is called angle of depression. Okay, and then you are supposed to calculate the distance between this person and the flagpole. So you want to find the distance from this person to here, so it means that this is wanted. So if I can show it here for you, for example, this distance is wanted. So you are supposed to calculate this distance by this information. Mainly the reason I brought this problem up is because I want you to know about these two terminologies, angle of elevation, angle of depression. I don't know why they call it angle of depression. Okay, so yeah, probably this is the correct word. The depression is coming from this word probably, because you go down, your mood goes down, yes? Anyway, so how we should calculate this D? And by the way, you know that usually when you want to make a flagpole, you make it perpendicular to the flat line, yes? So even though they haven't mentioned that, so you need to understand yourself that this angle is actually 90 degrees, but because otherwise your pole is not stable actually. And it doesn't worth to calculate because that number will change over time when it falls down, yes? So let us calculate this D. How should I calculate? Do you have any suggestions? This is a little bit harder problem than the previous one. Since I don't have calculators available here, I will write the exact answer. But usually, because this is an engineering problem or I don't know, a practical problem, very exact numbers is not very tangible or concrete. So you have to put approximations at the end. And it depends how precision you need in the problem that you're working with. But here I don't have calculator, I give you the exact value, and then you can put that number in your calculator if you're interested and calculate the approximate values. But a strategy is important. Do you have any strategy how to solve this problem? Yeah, it's a little bit convoluted, but I hope that you agree with me. Let me call this side. We don't know what that is. Let me call it X. Let me call this side. I don't know what that is. Let me call it Y. At least I know something about x and y by this picture. It's very immediately seen that x plus y is 20 meters. Up 20 meters. Okay, but my point is not to find x and y. My point is to find d. So I concentrate on this right angle triangle above, and I would say that 18, this x is the opposite side and d is the adjacent. So let us work with the tangent, yes? So what can I write? I can write tangent of 18 is equal to x over d. But let me find x from here. If I want to find x, I multiply everything by d. So x becomes d times tangent of 18. You see, this is a little bit a higher level problem because you need to have an idea what you are doing at the end, yes? I can do the same thing for this lower triangle, and I would write tangent of 22 degrees is equal to the adjacent side, which is y, but fortunately divided by the adjacent side, which is the same d. And then I multiply everything by d, so y becomes d times tangent of 22. And hopefully you agree with me that we are done. Why? Because x and y are unknown. I don't know them. D is also unknown. So I have 3 pieces of missing data, yes? How many equations do I have? I have exactly 3. 1, 2, and this one is 3. So essentially my problem is solved. 3 equations, 3 unknowns. In principle, I should be able to solve it. And then I told you that mainly the best way to solve a system, especially non-standard ones, are actually elimination or substitution method. But what is my goal? My goal is to find d, so it is better to get rid of x and y if possible directly. So let us eliminate x and y. How? I replace this expression instead of x here. I replace this expression instead of y here. So what would be the answer? So it would be d tangent of 18 plus d tangent of 22 is equal to 20. I hope that you are not confused here. What I want you to mention is that if I give you 5d plus 7d equals to 20, I'm completely sure every one of you can solve that. Because you would say that I add 5 to 7, it becomes 20, it becomes 12, and then I divide 20 by 12. But how did you say it is 12? In principle, it means that you don't care about d, you add 5 and 7. This is the way that you get it is 12d. This is the same story here. But the number is not that user-friendly, yes? Here, 5 is very familiar and very friendly to us. Here, this is tangent of 18. Who cares? That is a number at the end. But this is a not friendly number, but this trick still works. So it means that, in other words, I factor a d out, and then from here, tangent of 18 is left, and tangent of 22 is left. And this is equal to 20. But my unknown is d. So I need to divide 20 by this strange number. But don't worry, that's a number. It's a number from a different culture, probably, yes? This is, I would write meters here. So this is my exact value for d. But as I told you, this is more or less a practical and engineering problem. So it is better to put this in your calculator. And hopefully you know how to put it in your calculator. So you put 20, you put division. If you write it like this, that would be wrong, of course. If you just punch it like what I have done here is wrong. It's essential to put a pair of brackets around that when you want to type it in calculator. And then you just put it, I don't have calculator available, you put it in your number, and then you get some number. And then I don't know how many decimal points you want to keep, you keep them, and then you are done. Okay, so I really recommend you to do a lot of practice with this section, for this chapter. The lesson is not complicated. There are not that very hard concepts behind them, but it is technical. So you need to practice to be able to do that. And as I told you, there are very good problems in the book, especially level 3 problems. I will write on a school soft which pages I covered and which pages you need to do practice. Okay, so if you don't have any questions, thank you for being in the lesson. And then I just end this stream and be in Zoom for 1 minute if you have any questions.